Hello everyone, my name is Malcolm Eastman, and today we're going to be going over Ether Channel as well as Spanning Tree Protocol. So first I'm going to start with Spanning Tree Protocol and kind of explain what it is and why we would use it. Well, Spanning Tree Protocol is a layer 2 protocol that we use to prevent loops within our network at layer 2, right? So when we are talking about layer 2, we're thinking about MAC addresses, right? MAC addresses, switching, right? And we want to stop loops so that packets don't constantly loop within our networks, right? We can avoid things like collisions and things like that that would really hamper the efficiency of our networks, right? So as you can see here, I have three switches, right? Switch one, switch two, switch three, and I have some PCs connected to each switch, right? When we're configuring Ether channel, when we're configuring span tree protocol, we're going to be dealing with our switches. Our layer 3 switches also can, or multi-layer switches can also deal with spanning tree, right? So most modern switches are going to have spanning tree on by default, and you have PVST as well as rapid spanning tree, right? Generally, you see more rapid spanning tree in modern computer networks, but I'm pretty sure you probably encounter PVST as well, right? So how do we see our spanning tree, right? So I'm gonna just go into switch one. We're gonna go to the command terminal and we're gonna go into enable and then call T. And so the command we can do is do show spanning tree. And you gotta put a dash in between spanning and tree to get the command to come up. But also one thing also I forgot, you don't have to go into configuration terminal. You can just do it. You can see this show command from the exec mode, right? So I want to bring your attention to this right here. So we have two different IDs being displayed here, right? So it shows us what VLAN we're dealing with. So it's going to be VLAN 0001, right? That's just the default VLAN, right? And again, this is just for demonstration purposes. Obviously, you would configure each VLAN for each spanning tree accordingly. But you see the root ID, priority, the address, the cost, the port, and the hello time, right? And then the bridge ID. So there's two different IDs. Why do we see two different IDs? So this ID right here is our root bridge. So let me minimize this. So if we go back here, within this spanning tree instance, one of these switches is our root bridge, right? And whenever you whenever you do show spanning tree on your switch, you're going to see root ID, and it's going to tell you the root ID. The bridge ID, this is the switch that I'm in currently, right? So what determines the root bridge? So there's two different factors. So it's the MAC address as well as the priority. So if your switch has the lowest MAC address, then it's going to become the root bridge, right? If there's a tiebreaker, the priority generally is what's going to break the tie, right? And that's this number right there and right here, right? So you see the address for our root bridge. That's our MAC address for the switch, right? So our root bridge is our root bridge here, MAC address is going to be the lowest in our spanning tree instance. That's why this became the root bridge, lowest MAC address. And then we come down here to our interfaces. This is what we want to really, this is one of the things we really want to pay attention to when we're talking about spanning tree. How in the world does spanning tree stop loops? Well, let's take a look right here. So I have three different interfaces, right? I've got fast Ethernet 01, gigabit Ethernet 02, G0 or gigabit Ethernet 01. And then you have these different roles, status, and costs, right? So if we look at the roles is designated port, alternate, and root port. Designated port is going to be a port we're going to forward some our frames, right? So again, we're talking layer two, we're going to say frame, right? Even though the word packet and frame can be is used interchangeably nowadays when we're talking networks, but usually when you say Ethernet frame, you're talking layer two. Packets, we're talking about IP, you're talking layer three. But for the sake of this video, I'm just going to say frames. And it's in a forwarding status, meaning it's forwarding frames out, right? But take a look at this one right here. It says alternate and block, right? Alternate and block. So alternate, basically, it's an alternate port, right? So our designated port, just in case that goes down for whatever reason, we have an alternate, just as a backup. And then the status is blocked. This is how spanning tree stops loops. So let's go back to look at our network topology in whole. So if we look right here, right, and we have our three switches connected to each other, we can easily see how a loop can be kind of formed within this little our topology. So what we want to do is spanning tree is going to block a port so that we don't have loops, right? And let's take a look back again, which port that is that's blocked. And it says G02. So gigabit 02. And I believe, is it this? Yes. So this one right here is blocked. So this is the one that's being blocked. This is the one that's a designated port, right? There's one more port I didn't talk about, which is our root port, right? And that's our G0/1. So when we're talking about our root port, and which is this one right here, that's our port that's closest to our root bridge. So 001 is our root port. So our process of elimination, switch 3 must be our root bridge. Because again, our root port is always going to be the one that's closest to our root bridge. Okay. And another command I want to show you really quick, another show command before we start making some configurations. Let me exit out of configuration terminal. Let's go show spanning tree sum. So here in our spanning tree, this gives us a lot more information about our spanning tree instance, right? So again, we have it gives us the port fast default, port fast BPU guard, port fast BPDU filter default. Gives us a lot of different information, right? It also shows us it gives us VLAN 1, which again, this is the instance we're talking about. We got one blocking port, and then we got 0 listening, 0 learning, forwarding, and then how many switches are active in our STP is 3. So again, there's 3 switches that are active, right? And again, it also shows us what type of spanning tree mode we're in. Again, remember, right? It is PBST and rapid spanning tree, and it shows us right here that it's PBST mode. I'm going to show you guys how to configure that in a moment, right? And I'm also going to talk a little bit about port fast and BPDUs in a minute. So let's go into configuration mode. Let's look at spanning tree. So we can do a couple things. So like, let's take a look at all the commands we can do with spanning tree. So we got mode, port fast, and VLAN, right? Let's talk about mode first, right? So if I go into mode and I take a look, again, I have those 2 options, PBST and rapid spanning tree, right? So we can change what type of mode we're in, what spanning tree mode we're using with this command, right? Rapid PBST or PBST, okay? I'm gonna stay in PBST again, just for this video. But I also want to go back and show you guys some stuff for port fast, right? So with port fast, when we're thinking about port fast, generally what we're thinking about enabling port fast on interfaces that are connected to end hosts, right? Let's go back to the topology. Port fast and BPDU guard. we generally enable those on interfaces that are connected to end hosts, right? We don't want those devices to get BPDUs, so we put them in port fast mode instead, right? So let's go back, switch. So we can enable port fast BPDU guard on default on the switch. So we can do port fast in 2 days. We can do it from each interface, and we can also do it from the switch itself, right? So we can do, and then we can also enable port fast by default on all access ports, right? So BPDU guard, when we enable that, if we have somebody that plugs in like a rogue switch into our network, we would use this to stop ourselves from possibly being exploited by BPDUs, right? The BPDU attack, right, from a rogue switch. What would happen is the switches and the the interfaces that have BPDU and PortFast enabled will go into an error disabled mode, meaning that they'll shut themselves down. It'll be administrative shutdown, similar to port security, where if I have port security enabled and I have only the maximum number of MAC addresses is 1, and I have it to sticky MAC addresses. So it's like dynamically there in those MAC addresses. Let's say somebody plugs out that particular device and tries to plug something else in, it'll be error disabled. It'll shut it. Depending on the violation mode, it would be shut down. That would error disable it, administratively shut it down. All right. So we want to make sure we're doing that, making sure we're enable port fast default all our access ports. So I'm going to do that for the switch, right? So now I'm going to go back, and this is switch 1. So switch 1, PC1 here on all our access ports. And remember, access ports is ports that are going to be connected to our printers, if you have a laptop connected, our laptops, our PCs. We're going to have those as access ports, and it's going to enable those by default on our access ports, right? Trunk ports, right, switch to switch, are not going to be have port fast enabled, because we're gonna, we don't want port fast enabled on those interfaces. So I'm gonna go to switch 3, and you can also do it. You can also configure port fast through the interface, right? Conf T. Actually, even before I do that, I want to show you that this is the root switch. So one way you can see that this is the root switch, we're going to do spanning tree. And when you're on the root switch and you open up this show command, you'll see right here, this bridge is the root. So this is our root bridge, right? So you see it says this is our root ID, and this is the bridge, right? This is our root bridge, okay? Just wanted to show you guys that really quick. Because again, literally both of these are kind of the same, as you can see. Pretty much the same output for both. Okay. So now let us go into, and I know it's a fast, you have it on fast Ethernet. So fast Ethernet 0/0/1. And I'm going to do spanning tree. And then going to do, and then we're going to just take a look, right? So we can put don't accept BPDUs on this interface, right here. That's one of the things we can do to kind of protect ourselves. Again, protect our networks, our network from BPDU attacks and exploits. And then we can enable an interface to move directly to forwarding on link up, right? So when we do port fast, it goes straight to forwarding, right? We want to have port fast on our interfaces that are connected to end devices, right? And we can disable, and then we can also enable port fast on the interface even in trunk mode. So if this was a trunk, this is not a trunk port, but we can even have port fast enabled in trunking mode. But I don't want that, right? So I got a warning, right? Port fast should only be enabled on ports connected to a single host. Connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Use with caution. So again, we want, since this since this interface is connected to a end host, right, and I enable port fast, it's going to go into a forwarding state. If I enable port fast on a switch on another interface that's connected to a switch, this warning is basically telling me there could be a bridging loop. So again, you only want to use port fast on interfaces that are connected to end hosts because it's an end host. It ends at the printer, the computer, laptop, or whatever end host you have connected there, right? And again, it gives you the warning. It's telling you, hey, make sure you're connecting this to an end host, and your name this configuration is supposed to be used for devices that for interfaces that are connected to an end host. Okay. And then we can disable it we disable port fast for this interface right up here. We didn't want it no more, we can do that. Let's say this interface is not connected to another switch. We can just change that configuration by disabling it. Okay. So we can also change costs for our interfaces, right? And right here, we see the cost 19,414. Why is fast Ethernet cost 19? And why is these 2 gigabit Ethernet, these 2 gigabit interfaces 4? So fast Ethernet is going to be 19 and gigabit is going to be 4 by default. You can change that. So we can change this number, right? Let's say I want to change the number. I'm going to go to gigabit Ethernet 0/0. So I'm going to exit. Actually, I don't even have to exit out. Let's just switch the interface. G0/1. And I'm going to do spanning tree. And I'm going to do cost. And I'm going to do, and let's take a look at how high we can go. So we can go from 1 all the way to go to a pretty high number, right? It's always good to look and see when you have a configuration that uses a type of number. It's always good to, I like to hit the question mark to see, is it time we're dealing with, right? Is this measurement in time? Is it, how big is the number? How small is the number? How low can I go? How high can I go? Right? So I'm just going to do 20 just to make it higher than 19. So now I made the cost 20. I want to see if the configuration went through do show spanning tree. And when I pull it up, it shows me port. It's now 20. The cost is 20. Right? All right. So now let me exit out of here. Now I want to show spanning tree sum. Okay, so again, this one has 3 forwarding and 3 switches active. And again, we're going to look over here. We have our port fast disabled. So again, I only enabled port fast on 1 interface. I didn't enable it on all the interfaces, right? So I only enabled it on 1. And this one is disabled, right? Because I only enabled it on 1. And basically, port fast default is just activating it on all access ports. But let me show you. I did activate port fast default on switch 1. So let's go back to switch 1 and let's take a look. Do show spanning tree sum. And as you can see here, port fast by default is enabled, right? So again, because we did enable port fast on this switch, right? So again, all of our access switches by default or access ports by default are going to have port fast, meaning it's going to send it into a forwarding state because again, it's going to an end host. There's no chance for a loop as long as that interface is an access port. If it's a trunking port, you run the risk of having loops. And let me just show you how enabling BPDU guard. So spanning tree, and then we're going to do BPD. That's not BPD. So I'm sorry, support fast. So BPDU guard, and I believe it's default, if I'm not correct. Yeah, it's default. Default. And now, check this out. What happened? What happened was I received BPDU messages from these two switches, right? Since I enabled BPDU guard, what ended up happening, it shut itself down, right? So now this switch is not getting, it put itself administratively down, right? Administratively down, right? And it also here too, we got more messages. BPDU error detected on 01, putting 01 in an error disabled state, right? If you have a switch, if you have ports where you're expecting BPDUs, which is usually come from other switches, you wouldn't want to enable BPDU on those interfaces that are your switches, right? Like you've configured your network and you have switches that you've configured in your PortFast VLAN, right? And then you enable BPDU guard on interfaces like your end host switches, your end hosts, and then you enable PortFast. If a rogue switch is plugged into one of those ports, it would go into the error disabled port and the error disabled state. But if we enable it on ports that are connected to switches, this is what would happen, right? So this is what would happen if somebody decides to I'm going to take my rogue switch, right? And I'm going to try to plug into this network, right? And what ends up happening, we have BPDU guard enabled, and it shuts itself down essentially, shuts off that particular interface. So let's re-enable. Let's put it back on. Spanning tree. BP guard. Okay. So I just took off, no spanning tree. I just took off the BPDU guard by default, right? But nothing changed. I have to go back in and I have to turn back on these ports. So it's going to be interface G0/1 and 2. Oh, I've got no interface range. No shut. Now it's in a down state. Now it's not administratively down anymore. Now it's just down. Right. Now I want to show you that it's not administratively down anymore. Let's exit out. Let's go to exit prep mode. So let's exit again. Let's go show IP interface. So now it was, where is it? Oh, it's not showing me. Let's just do show. Okay, there we go. So see right here, it's error disabled, but it's down. Line protocol is down. Again, remember, it was down. It was error disabled because of the BPGU guard, right? I'm going to show. I want to make sure that it's still off, that the BPGU guard is now off. So we're going to do spanning tree sum or summary. So core fast BPGU default was enabled. Now it's off. Core fast is still on. So now, oops, technical difficulty. So now, yeah. So again, when we connect the switch to a BPGU interface that has a BPGU guard enabled, what happens is, again, it'll shut itself down, error disabled, right? So again, always remember, we have two different types of spanning trees, PVST and rapid PVST, right? Which most people just say rapid spanning tree. And rapid spanning tree is when we have a situation, we want to avoid a loop, right? We also want to be careful. We want to make sure we're enabling BPGU guards on our ports that we don't want to receive BPDU messages, right? So again, that's on we generally will put them on our access ports, because if you put them on our trunk ports, we'll have a situation where now it disables it'll disable itself, right? It'll disable those ports. So we don't want to do that to our switches that are connected in our network. We want to make sure we're doing that to access ports that are connected to and we can also do that. We also want to do it to switch to ports that we know are not going to be used in trunk ports. Right? So again, just to protect ourselves from somebody plugging in a switch that has, God knows what on it. Right. And again, remember, port fast puts our port into a forwarding state. We don't want to do that to our trunk ports. We only do that to access ports. And again, access ports, think ports that are connected to our PCs, printers, and hosts. So that's spanning tree, right? A very useful protocol to avoid loops. I kind of did a surface level dive into it, showed you a little how to change the cost, showed you the different types of ports, forwarding, designated, route, what makes a route bridge, right? How is a route bridge selected within a group of switches? Now I want to show you Ether channel, excuse me, because the reason I want to show you Ether channel is because they go, spanning tree and Ether channel do go hand in hand, right? So I'm going to open this other little lab I have, and I'm going to show you. This one's going to be really much quicker, much more simple, because it's just me just showing you like 2-3 commands and why you need to configure Ether channel on your in your network. You might possibly need to configure Ether channel on your network. So Ether channel, right? What Ether channel and spanning tree? The Ether channel basically gives us the ability to group multiple interfaces into like one single interface, right? It'll force the switches to kind of recognize that this is one interface, right? Obviously, it's two cables connected to each side of the switch, but we would I don't want to say trick, but we would basically tell the switch, we're configuring this as one single interface, right? G01 and G02 are one interface. Why do we want to do that? So the reason we do that is because if I decide over here to connect another Ethernet, another cable here to this switch, spanning trees basically is going to block one of those switching ports, right? Why does that matter? So let's say we're in the office. I'm your network technician, right? Network engineer. And you come up to me and say, hey, Malcolm, I'm having issues with my connection. My internet speed is kind of slow. John in marketing is not really getting my message. It's kind of like if he gets my emails, right? And I'm like, okay. And then next thing you know, another person, right, in that same department or same area comes and tells me the same thing. Right? Oh, I'm having connectivity issues. Or I'm not really getting all the emails. I'm kind of slow on the internet, or I'm just slow receiving and sending messages. So one of the things I would think, one of the things most people would do is add another connection to kind of increase the bandwidth, right? Of that from once our access switch, right? Our access switch is the switch that we have connected to our end hosts, right? So, John and Sally, they came up to me and said, yeah, my internet's kind of slow. My computer's running kind of slow. Can you help me out? What can you do about the network? I add another connection. But if I add another connection, basically it's just gonna, spanning tree is gonna kick in and just block that extra connection. So what I need to do is group those two so that they act as one interface, right? Because think about it. Let's say in this lab, I have two different PCs connected, but let's just say I had multiple PCs. I know we've all worked in an office building where, you might walk into the network closet or that data closet, and you're seeing all these switches, right? Can you imagine most of those computers that one access switch is connected to another multi-layer switch, and it's only one cable. Well, let's say it's a Cat 5e cable that's connected. It's saying it's going to get exhausted. It's going to be overworked, right? So that's why you might add multiple cables. But if you add multiple cables, then you kick in spanning tree. To get around that, you would configure the switch to recognize multiple interfaces as one interface. So I'm going to do that here. So I'm going to take this Ethernet cable, G02 to G02. It's going to block one of these, right? And again, let's just imagine we're in a big network. I'm only using these two switches and these two networks just as a demonstration of how to configure Ether channel. So the way to configure Ether channel is you have to make, again, remember I said two or more interfaces. I can't configure Ether channel on one, so I need to do multiple. I need to do interface range, right? So configuration terminal, and I'm going to go into interface range. And it's G0/1 to 2. Now I'm in the Ether range, right? The command to get into Ether channel is going to be channel group. Don't forget that little dash in the middle is what you need. It's just, so you need that dash to get into spanning tree, and you need that dash to get into channel group, which would be Ether channel. Now let's take a look what we got. So I got to name this group. So I'm going to name it 1. Oh, whoops, it wasn't done. And now it's going to ask me the mode. There's 2 different modes. Now we're in Cisco. One of these modes you're not going to see, like on Juniper switches, for instance. I'm going to show you. What's the mode? Let's do. So here you got to do a couple different options here, right? Active, auto, desirable, on, and passive. And it tells you what it wants, right? So you got LACP and PAGP, right? So one of these modes is only Cisco proprietary, and that's going to be PAGP. You're only going to see that on Cisco devices, right? That Ether channel mode, right? So since we're in Packet Tracer, right, I'm going to do desirable. Just, we're in Packet Tracer, we're going to use Cisco's proprietary Ether channel mode, right? So I'm going to hit desirable. And what happened was, again, if the reason I did desirable, basically, as you see here, is going to enable PHE unconditionally, right? It's kind of similar to, when you have your trunk protocols on, and it tells you it's going to form a trunk under certain conditions. So, you want two trunks to form. I'm sorry, you want the trunk to form between two different switches. You'd have to configure them accordingly to kind of recognize each other and say, hey, are you forming a trunk? I am trying to form a trunk, and then they would form a trunk together. It's kind of similar over here, where it's like, hey, us two over here want to configure an Ethernet channel situation instance, and then the two interfaces over here, if they're configured correctly, right, to recognize, depending on the mode, they're also going to recognize, oh, you guys are trying to configure an Ethernet channel instance. Us too. Which one are you trying to use? We're trying to do PAGP, and then they're going to say us two form the Ether channel. All right, so it went from down to up, down to up. Okay. So let's see if there's a show command for this. There is show Ether channel, right here. Show Ether channel information. So channel group listing, group one, remember we have to name our group, right? Group state L2, 2 ports, max ports, port channel 1, max port channels 1, and it's showing me the PAG protocol. Now I'm gonna go look at our other switch 2. I want to see what happened. Nothing happened. There's no group channel over here. Why is that? We didn't configure Ethernet channel on the interfaces over here. So let's do that. So we're going to conf T. And again, just remember, it's that channel group mode, channel group in command. Oh, excuse me, I'm not even in interface range. Excuse me, interface range. And that's going to be our G0, 1 to 2. Now we're going to do channel group, and we're going to name this one 1 as well. And we're going to do desirable. So now we got a different, now it shows us again, we went from down to up, down again, it's changing states. But there's another message here. Interface port channel 1, change status to up. Align protocol on port channel is changed to up. So now they have formed an Ether channel, right? We have properly configured them, right? Let's take a look and see what it says on this side. So exit, show Ether channel. And again, see, it's now showing us that there's an Ethernet channel configured here, right? So let us exit out of here. So again, remember, when we're configuring Ether channel, the reason we're doing that, we're trying to get one or more interfaces to be combined into one. Again, one of the main reasons most network technicians or IT technicians do that is because you might have some people in the building complaining about slow internet, slow connections, slow network performance. You would add another cable or another RJ45 from your access switch to your distribution switch, try and help that connection, right? Remember, again, this is layer 2. So if I can't do this from switch to router, right? Because that's going to be talking about layer 3. But I can do that with a layer 3 switch because, again, a layer 3 switch does operate at layer 3, but it also does operate at layer 2. Okay, so let's talk about really quickly what we went over. We went over two different things. We went over spanning tree as well as ether channel and why you have to know about both. So spanning tree is where we are trying to stop loops, right? We don't want loops within our network. We want to avoid that. Infinite loops, again, can really slow down our network, slow down our switches, our end hosts that are connected to those switches. And there's two different types of modes. You have rapid spanning tree and then PVST, which is basically going to be considered like your the default spanning tree that's going to be enabled on most network switches. And you can switch between the two different modes. We have different. We also want to pay attention to our root bridge, right? Remember, our root bridge is the bridge with the lowest MAC address. If there's a tie there, you'll use the priority number. And then also when we're thinking about, we have different roles for our ports. So today we saw designated, root, and blocked or alternate. And then there's different statuses, right? So our root port is basically usually the port that's closest to the root switch. Designated port is usually what we're going to be forwarding a lot of our packets to, or sorry, our frames through. And then alternate would be our kind of like our backup port, just in case our designated port goes down, we got our backup. And then we have our statuses, which is forwarding and block. So forwarding, we have more than those two statuses, but I'm just going to talk about forwarding and blocking. This is what we saw today. So our blocking is when a port is blocked. This will not receive frames. The reason we do that again is to stop the loops. And then we have our forwarding, which is going to be our port that's going to forward out those frames. Right. And we can change the cost of our ports as well. And one of the other things too, very important, BPTU guard and port fast. When we have port fast enabled, we want to enable port fast on access ports. The reason we want to do that is because those ports will go straight into forwarding, in a forwarding state, because we don't run the risk of a loop because it's connected to an end host, keyword end. You don't want to enable port fast on a switch, on an interface that connects to a switch, then that leads to another switch because there's not an end there, right? So then you can get a forwarding loop. BPTU guard, again, if you don't want an interface to receive BPTUs or send them out, you will put BPTU guard. And what that would do is if a BPTU guard is received on that port, it'll error disable itself like you guys saw in the previous little lab I had. And we want to do that because we want to stop rogue switches from possibly connecting into our network, right? Think of port security. If a rogue device plugs in, it's going to be error disabled. So whenever we're using spanning tree, we want to make sure we're doing port fast, right? Again, for our end hosts, and we want to make sure we're putting BPTU guard on those end hosts as well. We don't want to put BPTU guards on interfaces that will be sending and receiving BPTU's messages, because then they'll just go into an error disabled state, and then that will end up slowing down our network. Ether channel, you need to know both. Ether channel is the ability or protocol that allows you to combine multiple interfaces into one. Why do we want to do that? Because if we connect multiple interfaces, two interfaces to one switch, right? One switch to another switch, so access switch to a layer 3 switch, distribution switch, it'll start, or let's say it's to our core switch, it'll STP, spanning tree protocol, will kick in, and it'll block a port. Basically, we're back in the same situation that we was when we had one interface connected to each switch. So what we do is we configure Ether channel to configure multiple interfaces into one, so that we could still, get the benefit of using those multiple connections to get increased bandwidth while also still staying in spanning tree and using Ether channel. Again, and remember, there's two modes, PAGP and LAGP. One is a Cisco proprietary, that's going to be PAGP, and then there is LAGP, which is basically an industry standard spanning tree mode Ether channel mode. And then think about it also like LLDP and CDP. CDP is Cisco's proprietary network discovery protocol where you get information about different network devices on your network. That's something you're only going to see with Cisco, right? And LLDP is something you're going to see in just across. You're going to see it. It's on Cisco switches. It's also going to be on Juniper devices. So I think it's very, very important to recognize which protocols are Cisco proprietary or Juniper proprietary, because when you have a mixed environment where you have Juniper devices and Cisco switches, it's very important to understand what works on which switch and which doesn't. Because generally, if you have a mixed environment, you won't be able to take advantage of CDP, right? Cisco Discovery Protocol, and you won't be able to take advantage of PAGP because those are Cisco devices that works on Cisco devices. So that's why one of the reasons why you'll see a lot of networks generally will have all Juniper devices, all Cisco devices, so they can use those proprietary protocols, right? Some companies might like CDP more than LLDP, and vice versa. Some companies might like PAGP than LAGP. So again, it's very important to recognize those proprietary protocols. And this goes beyond networks. As you traverse IT, you're going to see a lot of vendors do have their own versions of a protocol, right? Or a version of that protocol. They have their own mode. So it's very important to recognize that and the pros, the cons, the benefits, and why certain companies choose to use those protocols over others. But yeah, so this has been Ether Channel and Spanning Tree, right? Again, this is pretty much a very basic, not a deep dive into either topic. I kind of just wanted to show you why you would use them, why they're, what's the importance of them, how you would configure them, kind of at a basic level. I didn't really go too deep into. I didn't really go into costs and all that stuff because I kind of wanted to keep it really basic. Focus on the fundamentals first before I kind of go into more depth about why you would use, how you would configure these in a much more advanced instance. But yeah, this has been Spanning Tree Ether Channel. Again, like always, if you have any questions, you can reach out to me on LinkedIn at Malcolm Eastman. And you can also reach out to me on my website at my email at malcolm@malcolmeastman.tech. And I look forward to seeing you guys in the next video. Please have a great day.